Hello everyone, welcome back to my YouTube channel. Myself Kushi.D from Sri Venkateshwara College of Engineering. My USN is 1VE20IS014. Today's topic is single level indexing of records by key. Okay, so what are we going to see in today's topic? So mainly we will be looking into the types of single level ordered indexes, that is nothing but primary indexes, clustering indexes, secondary indexes. And we will be seeing just the introduction part of multi-level indexes, dynamic multi-level indexes using B trees and B plus trees, indexes on multiple keys. Okay, let us see what is indexes as access paths. A single level index is an auxiliary file that makes it more efficient to search for a record in the data file. The index is usually specified on one field of the file, although it could be specified on several fields. One form of an index is a file of entries that can be written as field value, comma, pointer to record, which is ordered by field value. The index is called an access path on the field. So this point is important. The index file usually occupies considerably less disk blocks than the data file because its entries are much smaller. A binary search on the index yields a pointer to the file record. Indexes can also be characterized as dense or sparse. A dense index has an index entry for every search key value and hence every record in the data file. A sparse or non-dense index, on the other hand, has index entries for only some of the search values. Example, given the following data file, employee, it has name, SSN address, job, salary and so on. Suppose that record size R equal to 150 bytes, block size B is equals to 512 bytes and R equal to 30,000 records, then we get blocking factor, that is BFR equal to B div R equal to 512 div 150 equal to 3 records per block. Number of file blocks B equal to R by BFR, that is nothing but blocking factor, will be equal to 30,000 by 3, that will give us 10,000 blocks. For an index on the SSN field, assume the field size VSSN equal to 9 bytes, assume the record pointer size PR equal to 7 bytes, then index entry size will be somewhere equal to 16 bytes, then index blocking factor will be 32 entries per block, number of index block, that is 938 blocks, binary search needs will be 10 block access. This is compared to an average linear search cost of 15,000 block accesses. If the file records are ordered, the binary search cost would be 15 block accesses. Now let us see the types of single level indexes. That is, first one is primary index. Defined on an ordered data file, the data file is ordered on a key field. Includes one index entry for each block in the data file. The index entry has the key field value for the first record in the block, which is called the block anchor. A similar scheme can use the last record in a block. A primary index is a non-dense sparse index since it includes an entry for each disk block of the data file and the keys on its anchor record rather than the every search value. So in this slide we will be looking onto primary index on the ordering key field. So in this there will be 8 types of single level indexes clustering index. That is nothing but these are the 8 types of single level indexes. So defined on an ordered data file, the data file is ordered on a non-key field unlike primary index, which requires the ordering field of the data file have a distinct value for each record, includes one index entry for each distinct value of the field. The index entry points to the first data block that contains record with that field value. That is, you could see each one is mapped like this to the single key values. So it is another example of non-dense index where insertion and deletion is relatively straightforward with a clustering index. So types of single level indexes. So next one we are moving on to clustering index. Defined on an ordered data file, the data file is ordered on a key field unlike primary index, which requires that the ordering field of the data file have a distinct value for each record, includes one index entry for each distinct value of the field. The index entry points to the first data block that contains records with the field value. It is another example of non-dense index where insertion and deletion is relatively straightforward with clustering index. Okay, this is an example for clustering index. So in this we will be looking, see a clustering index on the department number ordering non-key field of an employee file. So you could see this is something like department number and this is the employee. We can see each one is mapped. So this is called as clustering index. Okay, this is another example for clustering index. Okay, this one is types of single level indexes. Secondary index. A secondary index provides a secondary means of accessing a file for which some primary access already exists. The secondary index may be on a field which is a candidate key and has a unique value in every record, or a non-key with duplicate values. The index is an ordered file with two fields. The first field is of the same data type as some non-ordering field of the data file is an indexing field. The second field is either a block pointer or a record pointer. There can be many secondary indexes and hence indexing fields for the same file. Includes one entry for each record in the data file. Hence it is a dense index. This is an example for dense secondary index. So in this we can see we have 3 blocks and each block is mapped to different blocks in the other part. So this is an example for secondary dense index. So this is another example for secondary index. We can see there is a single block for which it is mapped to multiple blocks, and from that multiple blocks it is mapped to another set of multiple blocks. So this is a perfect example for secondary index. So properties of index types. So types of indexes we have in the first column, number of first level index entries we have it in the second column, and dense of or non-dense that is in the third column, and block anchoring on the data file that is in the fourth column. So these are some of the properties of index types. So first property is primary. So in the primary, number of blocks in data file that is non-dense. So this block anchoring on data file will be yes. Next we have clustering. Number of distinct index field values that is nothing but non-dense, and it can be yes or no. It depends. Next, secondary key. So number of records in data file, that is dense, and it will be no. Secondary with non-key. The previous one which we saw was key, now which we are seeing is non-key. So number of records or like number of distinct index field values will be non-dense, and it is no. Moving on to the next slide, we have multi-level indexes. Because a single level index is an ordered file, we can create primary index to the index itself. In this case, the original index file is called first level index, and the index to the index is called second level index. We can repeat the process, creating a third, fourth, top level until all entries of the top level fit in one disk block. A multi-level index can be created for any type of first-level index, primary, secondary, or clustering, as long as the first-level indexing consists of more than one disk. So this is an example of two-level primary index. So this is nothing but the primary, okay, like the primary one. Then we are making one more level of indexing, and then we will be mapping. So this is called as two-level primary indexing. So next one we will be seeing is multi-level indexes. Such a multi-level index is a form of search tree. However, insertion and deletion of new index entries is a severe problem because every level of index is an ordered file. A node in a search tree with pointers to subtree below it. So this acts as a pointers. So this is a way how we use pointers to subtrees. So a search tree of order p equal to 3. So this is order 3. So the search tree of order p equal to 3. So this is an example for it. So dynamic multi-level indexes using B tree and B plus tree. Most multi-level indexes use B tree or B plus tree data structure because of the insertion and deletion problem. This leaves space in each free node disk block to allow for new index entries. These data structures are variations of search trees that allow efficient insertion and deletion of new search values. In B tree and B plus tree data structures, each node corresponds to a disk block. Each node is kept between half full and completely full. Thank you. Thanks for watching my video. Please do like, share and subscribe.